Welcome, everyone. I hope you enjoyed this week. I know I did. I was so excited to be here. It was my first in-person conference after since 2019, basically. So I was so excited to be here, and I can't believe it's almost over. So last stretch, folks. We have 3 more hours together. So let's enjoy it. I'm going to try to use this opportunity to start a dialogue and instigate some friendly discussion and constructive discussion around maybe some sensitive topics of contemporary C++. I very much enjoyed that term from Daniela. And if you don't agree, that's perfectly right. I kind of like that. You can shout at me on Twitter or use the mic, and let's have a discussion. So do ask questions as we go along. Comments are welcome too. Just raise your hand or maybe ask for the mic, and some of our friends in the green t-shirts will help you. All right. So our C++ community can be quite vocal sometimes. And when it comes to some sensitive or controversial issues, things can get heated up, and people are pretty opinionated, and they're trying to convince everyone that their way is the way. I'm not going to try to do that. So, like I said, I'm trying to start a discussion and hear your opinions on a few of the topics I'm going to touch today. We have to admit that we're pretty fragmented as a community. This is based on the breadth of the C++ ecosystem and the heritage we each bring and our experience in our industrial niche that we're working in. So it's only natural that we have different preferences or different strongly held opinions about various topics, maybe performance, code styles, best practices, code smells, and everything. And we've already seen a good sample of ideas around these topics at this conference. I attended some very interesting conversations, and I think I enjoyed most the follow-up discussions from these sessions and the Q&As, either live or afterwards. And I think this is the best part, and this is why we're all here, actually. And with apologies to the vegetarians in the room, I'm trying to push Bjarne's analogy of the elephant metaphor for how we see and use the language and tools that we have at our own disposal. So I think each of us kind of prefer a different bit of the language and a different way of using it, and that's all right. The diversity is good, and we have to accomplish very different tasks. So sources of good information are easily available nowadays, but this is a kind of a slippery slope. On the one hand, access to information is readily available on the internet, on social media, blogs, books, and so on. On the other hand, we have to be more careful in how we filter this information and how we judge it and how we apply it in a particular context. We might be talking about core guidelines or best practices, established idioms with fancy names, books, yes, they're still a thing, conference presentations, such as this week, and Stack Overflow, of course. And you have to take it at face value. So if you see something that looks like a hot take and looks like something that is maybe engineered to incite attention, you have to take it as it is and judge for yourself. And that includes this presentation as well. So mixed up in all the sources of knowledge that we have at our disposal, there's some obsolete things creeping up and that keep percolating, and they stem from old information that is still flying around, from things that we see in old code bases and old practices, some bad teaching materials as well. So we have to try to filter these things out and judge each idea, each strategy for its own merit and in its own context. And speaking of teaching C++, I think this is a very important topic, and I see a lot of very young people here at this conference, and I'm so glad when I see this. I see students, I see people at the beginning of their career, and it's very important to think when designing teaching materials and when imparting experience from our scars in the industry, it's very important to think about how people, newcomers to this field, to our language, to our community, how they perceive these discussions and what they can learn from it and how we approach teaching them and sharing our past mistakes. And it might not seem, some of the things I'm going to touch in this presentation, I selected just a few things. Some of these things might be obvious for some folks in the room, but I have heard them time and time again when talking to new people, with students. I frequently do guest lectures at my alma mater, and I'm always involved in working with interns. And there are recurring themes, and I selected a few of those to discuss here. So, speaking of teaching, I did a special session a while back. If you're interested into such things, or if you're involved in teaching yourself in a university context, maybe you want to watch that. And also, when looking for answers, we all do this. And don't think if you have a few years in the bag, we're not in the first diagram situation here. I find myself being a nice little kitty time and time again when I'm in an environment where it's unfamiliar, when I'm trying to learn something new. So we're constantly cycling through this through this thing, and we have to remember to be nice and to try to help others and not be smug and presume that everyone has the same experiences that we've had. So just try to be nice. This presentation stems from some kind of an improv thing that I did a while back with Jason. We kind of joked about this, and at some point we decided to actually do a live stream and tackle some of these things live. It was totally unscripted, live kind of thing, where I basically thrown things at Jason and try to see his reaction and try to take some tangents from there and see where the discussion goes. It's a long stream, so this might be the shorter version. And we're going to encounter, as a convention, the usual, I'm hoping most of you are familiar with MythBusters. Did you enjoy their show? So the familiar, confirmed, busted, and of course, because we're programmers, we have to have the it depends. So I'm gonna try to label things, but I'm sure not all of you will agree with the label I'm gonna attach to some of the topics. So that's okay, just jump in. So let's test this. IO streams are slow. Yeah, just kidding. I think everyone is okay with this. C++ 20 modules will solve all our problems, right? Packaging dependencies, build times, everything, right? It's all good now. Yeah. Not so fast. Coroutines actually shipped in C++ 20. Maybe, except for a handful of companies that can afford to heavily invest in building their own libraries to leverage coroutines. I think for most of us, it's just a nice exercise to just look at presentations and nod, like, this seems cool. And that's about it. We're going to get a generators library in 23. Looks like that's sealed. This is meant as a part of series of presentations because there are so many topics that we can discuss about. So I also friendly invite other folks that want to share their own opinions to jump in on this bandwagon. I'm okay with sharing. So if you want to jump into this series and present your own takes, feel free to do so. That would be very fun. In terms of referencing these, because people might want to reference things to their colleagues, to their friends, I used to like the Guru of the Week series back in the day. We each knew the right number, like the Guru of the Week 23. It meant something for a group of us, or the Scott Myers items. So I tried to give them some numbers there, totally random. So let's start. Usually when coming from a bad taste with iOS streams, people usually go for the saving solution. And that would be Printf or sPrintf. And the claim is that they are way faster than iOS streams. Well, the truth is sPrintf uses the global locale, and that involves a mutex lock. And just as a test case on macOS, where sPrintf is a part of the system libraries, you end up spending a lot of time in such a mutex lock related to acquiring the global locale. So you would spend a lot of the time just blocked. As a case study that I linked there in the slides, when you get the slides, there's lots of links and stuff, resources that you can investigate on your own when you have the time. There's a case study here where replacing sPrintf with the format library. How many of you are familiar with the format library? Oh, that is very nice to see. Like maybe 80% of the room. So, for example, on macOS, in this case study, they measured almost 4x speed up. That is 4x speed up in doing this replacement on macOS. And in Windows, there's a significant win there as well. So Printf is not the fast solution. Always prefer standard format. If you're on C++20, that's a luxury, I know. If you're not on C++20, prefer using the FMT library and the FMT print function, for example. And in general, I would say an important takeaway here is not to pick on Printf or to advertise FMT. The idea is that few people are aware about the standard functions that actually use the locale. And it's not always obvious. If you see something with a facet or a locale in the signature, it's an immediate flag. For example, you're using something with IO streams or sync streams or something like that. But in such situations like Printf, it's not immediately obvious. So folks should be aware of functions using locale. Tooling, our favorite subject to complain about. Humans always depending on tools to get their job done. And this is a frequent complaint we hear. C++ is not easily toolable. Personally, I've always been a tool builder. And I've always built tools for developers. And I think the problem is people are looking for the holy grail. They're looking for one tool to do everything. And we're never going to get that. Or they're looking for some standardized tool or some standardized way of dealing with certain scenarios. We're not going to get that either. but there are plenty of tools out there. We just need to learn about them at conferences, in blog posts, in demos, in case studies. Be it a profiler, or a fuzzing library, or a package manager, or a debugger, or a static analyzer. There are tons of tools out there for all platforms. So we just need to learn about them, share what we learn, and when we find the right tool that helps us for a particular workload, we have to learn it, like really understand how it works, really know all the knobs and how to leverage its power to solve what we have to investigate. So I think people usually use the C++ is not usually easily toolable thing because they just haven't invested enough time to find the right tool that helps them. So just try to learn about different kinds of tools. I always enjoy learning about stuff that I don't usually use. For example, tools from other platforms that I don't usually target. So I find interesting things and check to see if the tools for my platform or in my tool chain can do the same things. And I'm trying to learn more. So get to know your tools and get to know them well. Moving on, standard regex is too slow for production use. I have here just a very, very simplistic example, which, to be honest, I couldn't write without consulting the documentation. So the API gave me a bit of a challenge, so I had to constantly check CPP reference. And it just tries to parse a key value pair, kind of like a config file, something like that. This very toy example, very simplistic example, as short as you see it, it actually was so slow to compile, it actually timed out in Compiler Explorer when I played with it. So they are slow. They offer a very difficult to use API because they try to solve all world problems with this API. And with the current API, it's actually pretty hard to actually make them more optimal, more fast. The API is just broken, and we can never fix that, I think. So they're slow to compile, they're slow at runtime, and they come with gotchas. And we have to be very careful with the constructor when we're constructing the regex. We have to be careful with C matchers, and be careful where we put such initializations, in which function, avoid loops and such things. So they're definitely too slow. I'm going to pitch here the Ctre library. How many folks are familiar with Ctre, even if you have never used it? Too few hands. I would say a third of the room. So I've put a link here. Hannah is actually here with us. Over there. Hi, Anna. She's the author and maintainer of the library. Is very nice to use, easy to adopt in your project library. It is very fast. It constructs the regex at compile time, and it has a clean API. It works with the fancy new things like string views. So I highly recommend that you consider this for your next regex needs. Moving on. Question there. Can you take a mic? And be aware that Hannah is over there. Yeah. Okay, the comment from Jan is that you can't use Ctre when the actual regex is a runtime thing. Yes, but I would say that's more infrequent scenario. We're going to fix the mic situation. In the meantime, so feel free to jump in at any time, by the way. Question here? Sorry? Have I used boost?
Boost spirit key.
No, I have not. I have not. But my experience is that boost is kind of, you want some, you get all kind of situation. So you have to embrace it in bulk. So, but I have no experience with that library. This is a very lightweight library that is very easy to incorporate in a project. So you don't have any dependencies that you need to pull in. My experience is that not all code bases are boost friendly. Okay. Standard optional inhibits optimizations and complicates APIs. Let's write a very toyish example here. It's a serious C++ talk now. It has Compiler Explorer. Up until now, it was just vaporware. So we have an optional optional string that we get based on some kind of condition, and we want to get the size of this string. So very simple two-step thing here, and we see right away that we get the result we expect, the length 5 there of the hello string. We get it right away. So how does the compiler see this thing? If we squint really hard, we can actually make out that that funny number there is actually hell, and that comes from assembler. And the O would be right over there. So the compiler can actually see through this two-function call that we have here, and it will actually never get to call the get value through the get size function like we've written it. So basically collapses everything and just sees through it. Although we have some optional string in the way. So some folks are under the impression that using some kind of library facility like optional incurs some indirections and bloat and gives trouble to optimizers. That's not the case. We can be even more sneaky. So if we get a longer string there to avoid small string optimization, we immediately notice we have new and delete popping up because we're no longer in the small string buffer there. But again, the compiler seems to be clever about it and gets the 23 result there, although we're no longer in a small string world. So I would say in most scenarios, standard optional is not a barrier for optimization here. However, there are gotchas with standard optional. And for example, if we decide to hoist that string literal and put it into a local variable, like it's very plausible to be in real scenarios. So we made just a simple transformation there, and we might expect the same outcome. And I've taken here the two source files. I don't know if you're able to make out there are two tabs in Compiler Explorer, just advertising the functionality. If you're not aware that you can have multiple files in sort of like projects in Compiler Explorer, yes, you can. And I am even employing the fancy diff view that Compiler Explorer has. So with this small code change, we get more instructions generated, and it seems that things are behaving differently. And the problem is that we're copy constructing a string there. And why is that the case? I didn't. The comment was type mismatch. So yes, indeed, because we are returning an optional string from the function in the signature, and we're actually trying to return the string value there, which is a string, not an optional string. And we have this constructor from optional to blame for this. And yeah, this is a silent thing, and we need to be aware of this. We can silently construct strings or whatever T's we have in that optional. So we have to be careful when doing such combinations. The other part of this story is optional complicates APIs. And this one is a more difficult to try to tackle. Because the way I see it, we as a community haven't settled on how to use optional and for what purposes. And a frequent pattern that I see is that people use optional for error handling. And in that situation, you can get yourself in situations where you get into a mix of things when you try to compose functions. So, and another thing is that there's a huge temptation to actually unwrap the optional. So we have to resist that temptation to look inside the box, to check if we have a value or not when we have a chain of such functions. So we're going from a function producing an optional value to another function that takes an optional value and so on. So I would say we're new to this game, so we might benefit learning from other facilities like maybe type and option in other programming languages. So we would have to think in terms of higher order functions. I know this is not something that many folks are comfortable with, thinking in functional terms, in higher order functions, and transformations in this way. But this is the right way to approach things. Instead of trying to unwrap at each step and check if and guard if we actually have a value or not, we should think about chaining transformations. And yes, I'm going to use the M word. I have a link here to a very nice article that tries to explain things like fmap and applicative and monads and so on in a very simplistic way. So it's not a dry mathematical approach. And no, it doesn't imply Haskell. So luckily, we have monadic extensions to standard optional in C++23. And even if you're not on C++23, there are implementations out there like size optional on GitHub. Just look for Tartan Llama optional if you're not on 23. So the idea is not to look inside the box at each step when we try to compose functions rather than build continuations. Let's take a very simplistic example. Let's say we have a string and we need to produce an integer from that string. The implementation is not relevant, it's not important. The idea is that we might get an int or not, depending if that thing is parsable to an int. And if we want to do something with that integer, we have to think about this in terms of phases of transformations or phases of propagation of that value through our pipeline. So where we have the and-then continuation that receives an integer value and produces an optional integer, and maybe we do something with that. And then we have another transformation that maybe produces something with that value, if it yields a value. Or else we do something else as a fallback. And only at the very end, we're actually poking the value. We're trying to extract if we have a result or not. And we can use value or we can query to see if we have a value, or whatever we prefer. So the idea is that we chain these transformations without actually checking at each step if we actually yielded a value or not. And we assume that it all went fine. And at the very end, we check if we actually produced the result of our pipeline, of our transformation. So I think with proper usage and with inspiration from other programming languages and with facilities such as monadic optional, I think it doesn't complicate APIs if we're trying to adapt, but we have to adapt. And for the next part, we're very good with names, aren't we? Standard move doesn't move. Someone at this conference already talked about the experience of meeting standard move for the first time. Standard forward doesn't forward, spoiler. Standard remove algorithm doesn't remove, no. And standard function, it's not a function. Let's try to analyze the standard move, because I've heard this one time and time again, and it always freaks out people that are new to C++11 or new to C++. Let's take a very simple example once again. We have a function that it just echoes the two parameters there, and we pass a string that we just constructed. Nothing tricky here, the expected result. Let's try to move the greeting into the first parameter there. Same thing? Anyone surprised at this point? No? This is the interesting bit. What if we try to move on both parameters there? And I've actually seen people freak out when encountering such things. What do you think it will happen? Same thing. Why? Just shout out. One at a time. It doesn't move. Basically, I'm restating what you said. And the idea is that we're actually casting to that reference type behind the scenes. Move is just an adapter. And that R-value reference can be bound to our const string reference that we have in the echo function signature there. So basically, nothing happens. But what if we take out those references? And I'm going to pick on that pattern just a few slides down the road. So what if we take out those references and now we have just some strings as arguments? Does anything change? So we get hello from string and nothing, a string that was moved from. And the interesting bit, and yes, indeed we have the move constructor there for the string. A move actually occurs. And this is what actually happens on Clang. If we move to GCC, it's the other way around. Go figure. So just remember that standard move does not move, and then you're not going to be surprised anymore. And if you want to learn all the nasty details, I hear there's a 200-page book about move. I try to remove some references in the echo function earlier. And another well-established practice is that we always pass input arguments by const reference. This is the kind of thing we're used to seeing, yes. But there's a new pattern that started to appear in the latest period. And that is since we have move semantics. And I think we've all written something in the lines of this, a simple two-part constructor there, one taking const reference, one taking an R-value reference. Nothing fancy here. Things get really messed up when you have more than one argument. So it's a combinatorial problem here. I wouldn't want to write something like this, but I did at some point. So an established idiom, it usually goes by the sync name pattern, sync argument pattern. How many have seen this before? And how many are comfortable with it? Okay. Some people are very uncomfortable seeing those strings passed by value in the constructor, still. So let's try to see just a bit about what happens. So the idea is that we're constructing this widget and we're trying to take ownership of those strings. And we might try to do the same thing, for example, for a setter. How many of you are comfortable with a setter taking things by value, as opposed to the constructor? Okay? Fewer hands, but still, I still have some allies. So, same thing. We're trying to take ownership of that value. And let's try to analyze what the operations involved here are. So, we're passing here a string literal to the setter, and we have to create the string from the literal value, and we have a move assignment into the data member according to our implementation. Okay, easy to analyze. Let's hoist that string literal. We have now a local variable string, and we call the setter. Now we create a string with a literal value, we make a copy of the string, and we have a move assignment into the data member. Everyone following along? Now let's move it. Let's assume that local variable is no longer needed outside of beyond this point, and we just move it into the setter. In this case, we create it just as before. We move construct the string into the setter, and we do a move assignment in the data member according to our implementation there. If we decide to implement all the possibilities there and go for the maximum performance, we might try to have both the const reference overload and the R-value reference overload for set name. Again, this is a luxury that we can afford when we have one, maybe two arguments there. And in this situation, we're creating the string with a literal value, and we make a copy of the string in our setter, and that's it. And yes, in such scenarios, this would be the most efficient version because it saves a move operation. But think about it. It's a fraction of the use cases when you actually benefit from having those overloads, and you're actually saving one move operation. You can argue that the move operation for that type might be expensive, and even for strings, given the internal buffer for small string optimizations, it's not negligible. But I think in most situations, we benefit from having a nicer API. So I would encourage you to leverage the sync pattern when you can, because I think it simplifies things. And if more people get accustomed to it, it won't look so scary for others. And there's even a clang tidy modernizer check that can do this transformation automatically for you at scale. So you can run this transformation on an existing code base, and it does these changes for you. It works out really well. Adding const always helps. Hey, Jason, are you still here? Yeah. Const all the things. I think we've heard that frequently enough. And there are situations where this is counterproductive. And if you haven't seen this short video from Jason of top 4 places to never use const, I'm going to give you just the digest version here. So don't const non-reference return types. Don't const local variables that might need to take advantage of move on return. We've already seen a presentation this week on problems and gotchas with RVO and named RVO and things that compilers can and cannot do in corner situations. And in general, this wouldn't be beneficial, so it will definitely prevent move on return. Don't const non-trivial value parameters that you might need to return directly from the function. I've seen time and time again people consting arguments that are passed in by value to their function. I really don't see the point in doing that. Aside from maybe guaranteeing that you're not touching it or changing it inside the function. But it won't help, again, with move on return scenarios. Don't const any member data. Again, if you want to preserve invariants for your type, there are better ways to do this. This implicitly breaks implicit and explicit moves, and it breaks common usages of assignment. So, no, const is not always good. Make all data, speaking of data members and guaranteeing invariance for a type. Making all data members private is typically seen as a good practice. We're all very good Java programmers, yes. It enforces encapsulation, the object is in control of its internal state, you can guarantee enforce invariance, and you can document access patterns and so on. Yes, they're all good advantages. But we have to think about narrow and wide contracts for our interactions, for our protocols, for our functions that we provide. And we have to think about not adding complexity where it's not needed. Again, Guy talked about abstraction and how we build types and how we build interfaces. And don't try to add everything that you might need in the future. If you don't need to guarantee any invariance for the type, if you don't need all the setters and getters, don't try to implement them right away. It will add complexity to your types, and it will inhibit other operations that will happen magically otherwise. And maybe you don't need constructors either. We can leverage direct initialization so many times, which is actually faster. So don't jump on implementing constructors just because that's how we do it. Sometimes structs just want to be structs, and I think that's okay. And I highly recommend this presentation by Ctre Library on Abstraction Patterns. And she talks about, among other things, talks about protecting invariants and how to design types and proper abstractions. And if we're talking about structs, again, I'm going to try to touch an uncomfortable topic. And I'm going to reference Mike Acton's keynote from CppCon on data-oriented design in C++. If you haven't seen it, I highly recommend that you do. It's all about writing software as data transformations, as processing data transformations in stages efficiently, and how performance is all about smart data layout and memory access patterns. And I think we should spend more energy in how we build and design our structures rather than how we encapsulate and expose their internal guts with fancy accessors. If you want a modern take on this, this is another good presentation that I recommend by Andrew Kelly, the author of the Zig programming language. Again, practical guide to data-oriented design. Moving on, I think we've all heard this one. Iterators must go. This was a highly influential presentation by Andrei Alexandrescu many years ago. And I always saw references to it, but I never got a chance to see the recording. And I finally found a recording archived somewhere. And I've put the link here if you want to see it. I'm going to try, bear with me, I'm going to try to do a Romanian accent. What's up with that? Destroy. So somebody did destroy. The talk was so influential that it even pissed off Alexander Stepanov. He actually said at some point that Alexandrescu is on a crusade to eliminate iterators. And this talk from many years ago actually paved the way to ranges and piped transformations. And some people seem to think that now that we have ranges, iterators are no longer in good fashion, they're no longer useful, and everything should be done exclusively with ranges. Well, if you want to learn more, somebody did proper destroy, but it took almost 12 years. Again, if you haven't seen this presentation by Barry Revzlin, I highly recommend it. It's very, very good. A very in-depth analysis of many scenarios of using iterators and ranges, and it's a comparative study between C++, D, Rust, even, I think this version of it even has Java and C# variants. Very interesting analysis on the way each language designed its iterators and the way it produces values, and the way you can compose it, compose functions to implement algorithms with ranges or iterators. So advantages and disadvantages on either side. And I would close with, I think, one of the saddest things I keep hearing is that all new things are just fancy constructs that basically keep us busy learning new things instead of actually producing code and working. And every new feature that a new C++ standard brings, either in the language or the library, is just a fancy way of doing something that we've been able to do all along. So the new is always the the enemy of the old. So I think we have to be, we don't have to be overly enthusiastic. We don't have to grab and use everything, every shiny new thing. But we have to try to see if it can really help us, and we have to figure out how it's best used before sprinkling it all over our code base. As a closing, I recommend some more myths. If you haven't seen this presentation by Patrice Roy from 2019, some programming myths revisited. Very fun talk, very fun talk. I always enjoy presentations from Patrice. More myths, more controversial stuff than what you've seen today. So very fun. So I invite others to join in and bring forward more ideas, more discussion, and I'm going to approach more topics along these lines. Some of them are listed here. I plan to touch on these in follow-up presentations. And yes, to be fashionable at C++ conferences, you have to have Rust stuff. So yes, I'm going to touch on some Rust topics and borrowing and lifetime annotation stuff. That was it. If you have comments and you want to shout at me, I'm here.